Hello and welcome to part 3 of our virtual field day on soil nitrogen tests brought to you by the Corn and Soil Health Project at the University of Illinois. In this particular episode, we will be taking a closer look at the SLAN and Solvita tests. And we will be visiting with Will Brinton of Woods End Laboratories.
Greetings, my name is Will Brinton, and I'm the founder of Woods End Soil Lab, which I first developed while I was still an undergraduate in agronomy, but focused on organic farming development and building scientific tools to help growers do things better without all the reliance on chemical support. So one of the early questions we had in starting the lab was, what kind of soil tests are appropriate for biologically managed systems where you're not relying on external nutrients to bolster crop yield? And we did have external nutrients, of course, in the form of natural minerals. Certain kinds of mined minerals are acceptable organically, but we certainly didn't have soluble nitrogen of any kind at our disposal, so learning to manage the soil's nitrogen cycle was critical. So in the early 90s, I gave a presentation at an Oxford University conference called IFOAM, the International Federation of Organic Agricultural Movements, and I proposed a new biological indicator of soil health based on soil CO2 respiration. And that was the origin and genesis of Solvita, which today everybody knows Solvita with these color charts. What we did is we just developed a chemistry that's almost identical to what's called base trap chemistry, where as carbon dioxide soaks into a solution, it starts changing the pH, and the pH can be indicated accurately by these colors. And we calibrated this to the range of respiration that would be common in soils. And we had a lot of debate and discussion between Europeans I had worked with and people like John Duran in Nebraska, who were early forerunners in soil quality testing. And he used to tease me and say, don't only make it for organic growers, make it for everyone. So as a result of that, we calibrated it to be sensitive to very low respiration rather than high. And that's the system known as Solvita today. Another test that we developed, the Slant Test, and this extracts amino nitrogen from the soil and gives a similar chemistry range. And because of my background in chemistry, I knew all I had to do was convert the amino compounds into ammonia compounds. And you can do that simply by adding an alkali to soil. So it freed them into the air where we capture them with one of these paddles. And we have since calibrated that. Now, I will say these tests don't give direct indication of what's going to be released. They're all indirect indicators. In other words, when you have microbial respiration changing the color from blue to yellow, that will tell you the soil is extremely active. It still doesn't tell you how much nitrogen is involved in this transaction. Whereas when you get the soil to change from yellow to blue with the amino test, it does tell you that there's increasing amounts of protein and amino acids available in the soil, but it doesn't tell you exactly how much has been released. And it turns out this depends on where you're located, your climate, your rainfall, your soil history, and so on. And that's where all the tweaking and the fun part is, because we're really working with growers to calibrate it for their particular farms. And it's really the only way forward is to use these kits in the field. Laboratories can do it, but laboratories just do it in a very generalized way because they're getting client samples from all over the place. We think the more we can get these tests to the locale and to the specific soil, the better chance you have that you have a result that you have validated for your kinds of crops and your kinds of soil conditions. Well, if you are using cover crops and manure, you can be certain that you're going to get higher results with any of our tests. And Also, because manure, when it's spread, doesn't necessarily go down very evenly, you can hit hot spots and low spots. So I tell people be very careful in mixing soil. We tend to recommend, if you're going to get a representative sample, you take at least 12 samples and mix them all together from 12 different locations. So it's a lot of work. And that reduces some of the spatial variability and the non-homogeneity of manure spreading. Obviously, if you see there is some manure in a sample, I guarantee you'll get a very high CO2 respiration. Often manure has enough ammonia and amino acid in it that it would also affect our amino nitrogen test. The best time, of course, to test is when manure has already been incorporated into the soil, or if it was surface applied, it's had time to work itself in. And with cover crops, it's fun to test them while they're growing because you get very high levels of respiration. But be aware when the cover crop is terminated, it will decay and then the roots will disappear and the respiration will drop back down again. And you may want to notice that and sample later in the year, depending on what's growing there. So there's a lot of caveats to this, but the best way to think about it is that soil life is a cycle during the year. It's not one fixed thing. There's not one right way to test it. And the best thing is to try to become familiar with it in the course of the year.